And there winds up being a relatively easy and very systematic way to approach these exponential equations. Right? And that approach is look to rewrite each base so you're going to rewrite each exponent using the same base. Okay, so when you look at the bases 9 and 27, what can you rewrite each of them as? What's the base that you can use to express each of those? 3, right? Because 9 is 3 what? Okay, so if you think of 9 as 3 squared to the x plus 1, and you think of 27 as 3 what? Cubed to the x minus 1, what you can now do is you can apply the properties of powers. Right? When you take a power to a power, what do you do with the powers? Multiply. So you get 2 times x plus 1. And then on the right side, we get 3 to the power of 3 times x minus 1. Okay, so you'll rewrite each one with the same base. Then you're going to apply the properties. Okay, and then what you're going to do is, since you have the bases the same, you're going to equate the powers. Okay, so whatever the powers are, you're just going to take 2x plus 1, set it equal to 3 to the x, or to the times x minus 1, and then just solve the resulting equation. So if you distribute your 2 through 2x plus 2, distribute your 3 through 3x minus 3, you'll convert this into an equation that's of the linear equation form, or possibly quadratic, but a different form that you can solve. And then just solve for x. In this case, isolate your x by subtracting 2x from both sides. At the same time, we can move our constants over by adding a 3, and we get the solution to be 5. Okay. Any questions on the process there? Yeah, Sean. Well, the base came into play as we set it up, but once you actually equate the powers, you don't have to worry about the base. As long as they're, I mean, and you should see and recognize, they're going to be small numbers, right? The base is either going to be 2, 3, 4, maybe 5. I mean, it's going to be relatively small numbers for you to work with. Okay, so let's take a look at another example. In this problem, what can we rewrite the bases as? So, guys, quiet, please. So you get 5 squared to the power of 2x plus 1/2 is equal to 5 cubed to the x. Okay, now you apply the properties of powers. When you take a power to a power, you multiply. So you get 5 to the power of, let's distribute our 2 through. So we get 4x plus 1 is equal to 5, and then 3x. Equate the powers. 4x plus 1 has to equal 3x. And then solve for your variable. Subtracting the 3x from both sides. At the same time, move your 1 over, and you get your answer to be -1. What's happening here? Can you rewrite the base on each side? If you add 1 to both sides, you get 2 to the x is equal to 6. Can you express 6 as a power with a base 2? No. So there's an alternate form. When that doesn't work, so look to use that method first, because the method where you can rewrite the base as an exponent using the same base is the easier one, the one that you can do by hand. But if you can't, then you will have to rely on using a calculator. And the way that you will do that is you'll isolate the exponent with the variable. Okay, once you isolate it, you're then going to take the log of both sides. Okay, now, you can choose either one. You can take the common log or natural log. Again, my suggestion would be based on which calculator you're using. If one of those keys shows up and is easier to use than the other, I would do that particular operation. So I'm just going to use the ln for this example, but I'm going to show you that they both work. So if you take the ln of 2 to the x is equal to the ln of 6. Okay, what you'll then do is you'll look to solve for the resulting x. So we'll apply the properties of our powers in logs. We can move our exponent down, right? This becomes x times the ln of 2 is equal to the ln of 6. And then divide by ln of 2 to completely isolate your x. Now, does this equal the ln of 3? No, it doesn't cancel that way. So what you're going to need to do is use your calculator, ln of 2. Put it into decimal form. Hit enter. You get your answer 2.58 approximately. Okay, I want you to see here, though, that if you took the natural log, so log of 2 to the x is equal to log 6. Again, move your exponent out front and divide by the log, common log, 2. To solve for x, you're still going to get the same thing. So if we use green diamond 7 for our shortcut, log 6 divided by log 2 in decimal form winds up with the same thing. It doesn't matter which one you choose, they're going to give you the same value either way. Patrick?
It worked this time, but can you also just do it the way where you just take the log of 2?
All right, let's take a look at the solution for this. All right, step 1, isolate your exponent that has the variable. So we're going to leave e to the minus x alone, add 6 to both sides. Okay, now, which log should we take for this? Natural, and the reason is it has an e in it, it has the natural base anyway, so you might as well take the natural log of both sides. So ln and ln. This whole value is going to come out front, so negative x times the ln of e is equal to the ln of 15. Well, what does the ln of e equal? 1. So this is all just a value of 1, so you can eliminate that as effectively. It's multiplying by 1, it's just the value itself, negative x. And so all you need to do now is multiply or divide by a negative to get the x completely alone. So you get negative ln of 15. And if you wanted to put that into the decimal form, you can just type in ln 15, put a negative in front, and change it into a decimal. And you get your answer to be about 2.71, or negative 2.71. As your solution. All right. Questions on that? All right. Yeah, Marina.